Hey YouTube, welcome back. And today we're going to model Intamin track. Now, if you've followed me for a while, like for 4 years, there's a video on YouTube, I'll put a link in the description, of a pathetic dude spending 10 minutes to model a track piece and then having to redo that multiple times, which is hilarious to me because I've learned a couple of other new little tricks that we'll go over in this video on how you can, enhance your design of your track. And we're going to focus on a triangular track since on that one I did the square box track, and I did a totally different way of modeling it where it was more heavy on Solidworks and not so much in the Excel setup. So we're going to do more so heavy on the Excel, and then we'll dive into how you can model it in a CAD program, and I'll be doing Solidworks. So I think it'd be a lot of fun. We're going to dive right into it. As I said, we're doing triangular track, so I have a little diagram of what we're going to be going for today. This is all in meters. It's close. It's not perfect, but this is what we'll be doing. And if you're going to go and model some track to be, 3D printed to make a model or whatever, you can set it up whichever way you want. I'm just going to kind of go over the procedure to set everything up, and then we will go from there. So, like we've done in past videos, we're going to set up our rail gauge. And as you can see in this drawing, it's 0.55, so that's easy peasy. And just like the previous video, this is gonna get kind of boring. You're gonna be like, dude, we've done this every single time. It should be the same. I'm just gonna go over for the newbies that just came in, like, I really wanna know Intamin track. I don't really care about all your other videos. I don't have a half an hour or an hour to go and watch all those. So I get it. Everyone's busy. So we're gonna start with the left rail and the right rail. And if I'm going too fast, go back an episode, go back 2 episodes, and we'll talk about all about what we're doing here. So for our left rail, for the X, we're going to do X position, and then we're going to add our left X times the distance, which is half our gauge, right? We'll set that up and bring it over just like we've done before. This should be very, easy, and if you've been following me now for the past few videos, this is trivial. So now we're going to do the right rail, same thing, X position, and we're going to subtract the left X times our gauge, right? So nothing new here. We've done this before, and I'm just doing this in Excel to visualize what's happening. You can program this in MATLAB or code it however you want. So now we're going to start diving in to where this gets a little different. So we need to have, I'm going to call this a secondary rail point. And if you look at Intamin track, there's on these cross ties, it doesn't actually go up to the rail. You can't use this same point, so we need to offset it over. And I like to imagine it as a secondary rail. So do the exact same thing. You do it right over. The only thing different now is this distance is going to be different. So for this example, it looks like we have 0.38, so we'll set that. And then we will do our secondary rails. So let me grab our tiles here. As you can see, I just call it second left rail XYZ, and then we'll bring it over. So let's just start with this. And as you can see, it's the exact same equation. We're just going over, grabbing our X, and then the only thing that's different compared to when we did our original left is now our distance is different because we're not going that 0.55, we're going to 0.35, 0.38. So that's the only difference there. And then we're just doing the exact same thing. So what we have now is the point of which our actual rail, the running rail, will be on. And then now we have the point of where we're going to connect the cross tie vertical parts of the triangle. So it's very straightforward. And then we have to do it for the right side. So we're going to do the exact same thing, only now we're going to do positive X minus the left X times this new 0.38 distance. We'll bring that over. So everything should be pretty straightforward as of now. All right, and then we need just one more point for the bottom, the spine, right? So let's just keep going over here. We'll call this spine. And in my drawing that I just kind of sketched up in SolidWorks based off some Google images, I'm gonna go 0.95. That seemed to be pretty close. It might actually just be a solid meter. I don't know. Talk to someone that worked at Intamin, or heck, this would even work for a Gerstlauer. You might want to change up a few things later on, but pretty much the same procedure. All right, so spine, X, Y, and Z. You've done this before. If you watched the last video, we're just going straight down. So let's take a look at the equation. Positive X minus, because we're going down, the up X times whatever distance we said, which is 0.95. Look at that. All right, and there we go. Bring it over, bring it down. Guess we don't need this last one. So, with that, you have now just programmed all the points, all the curves you're going to need to bring this into a CAD program. And that took, I don't know, a couple minutes. And what you can do is as you go through your entire track, you just bring it in and then all the equations are set up. So it's really, really quick. Now, the next step to get it into Solidworks is you go to Notepad, grab your coordinate system like we've done before, put a Notepad, save it as a text file. And you know what? You can actually save Excel as a text file. Just bring it into like a new sheet and then put your points in there and save it. So there's other ways you can do that, but I've already gone and saved all these files for us. So let's just dive right into SolidWorks. All right, so now that we're in SolidWorks, what we can do is we can bring in our curves like we've done in the past. Like I said, I have a macro that we'll kind of dive into in another episode. But all it's doing is just bringing in these curves using what we talked about last time about how you can bring your X, Y, and Z points and then create a curve from those. So that's what this is. So that's the left and the right rail and our spine. And then what we need to do is bring a point cloud in. The point cloud is basically our secondary and secondary left and secondary right. And let's do that right now. So bring in our points, and there you go. We're going to use this to construct the triangular, it's basically like the connector between cross ties. If you look at an Intamin track, on some of the older ones at least, there is the square tubes that are the cross tie, and then there's a circular tube that is like a cross tie connector. So let's dive right in here. Since we're in a 3D sketch, we're just going to start making cross ties. And there is a way to automate this by knowing which points are connecting each other, and that kind of takes the design to a whole nother level. So let's just kind of sketch this all out and then go from there. All right, there we go. Those are the cross ties. So get out a sketch. We're gonna do weldments to create the cross ties, at least in this example. So before, in episode 2, you saw me take a surface between the two curves and just pattern the cross tie. You can do that. This one's a little more prescribed to the Excel data that we had. So both ways work just fine. For this, you'll get a better result. So we're gonna go into weldment, structure members, and I created a profile. So if you go online, you can search how to make a weldment profile, but basically it's just my square tube. I just called it Intamin full. So we're gonna use this and just start selecting our cross tie. And as you can see, it'll load right up. And what we'll do is we'll just align it to these guys. We'll just go one by one and make sure we get it all set up correctly. All right. There we go. So now we have our crosses, and then we're gonna go and do the V's. So similar way here. So we got our cross ties. Now, what we're gonna do next is a bit, I don't know, kind of up to you on how you wanna model it. So first, we have our cross tie that's at the beginning. It's obviously where the two track pieces butt together, so I'm just gonna cut it in half. You can set it up however you like, but for this demonstration, we're just gonna cut this guy off. And then we're gonna do the same for the other side, and we'll work from there. So let's do the other one. Just make a plane and cut it. And what we're gonna do is, like I said, this is kind of just if you wanna go 3D print your coaster track and whatnot. So all we gotta do is just make sure this is 3D printable. And that means you can do a couple things. You can make your, let me center this, your bottom spine you could make it and then as a weldment trim it. And that takes a lot of time. And that's the correct way, because then you can actually get the cut paths for all of your weldments. But I'm gonna cheat just a hair. And we're going to draw on this plane here. I said I'm gonna cheat a bit, but let me show you what I'm thinking here to make this a little easier. So we will grab our circle and we'll say what we said. It was 0.14, and right where it's kind of nicking off here, I'm just gonna make it a little bigger. And this is the poor man's trim, as I like to call it. And we're gonna sweep this through, and it should work for what we're doing. Actually, just to like, what you're gonna notice is you're gonna have to sweep it and then curve it. So in order to adjust for that, we'll actually bring this down just a hair. We'll make this 0.12. That should still, see, even if it rotates a bit, we'll be okay. And you'll see that, or see what I'm talking about in a little bit here. All right, so see how it curves a little bit? So that's okay, and then we will trim it. There you go. So now these are all trimmed up to the correct distance, and then now we can go and add our rails in. Looking good. So we will do sweep, circular, 0.14 like we said. Next sweep, circular, 0.14. Bada bing, bada boom. Feature. Losing it. 0.14. Look at that. We are almost there. And now let's just make this a little more visible. We can probably turn these curves off so we can see. We can combine everything so it looks beautiful. All right. And now we can do the last thing. So on this type of track, and this applies to Intamin or Gerstlauer, there's circular tubes that go either in actually a zigzag, or sometimes even it's just same parallel cross ties. So let's just go ahead and model. I'll just do, I don't even know, let's make it correct. So I think if we do it like this, this is actually how they look. All right, now we got our sketch. I think, you know, what we'll do is actually, I'm gonna go back into this and we're just gonna go connect the rest before we go and attach everything. So we should be able to go like this. All right. There you go. Oh no, I got one floater out here. Let's fix that guy up really quick. All right, there we go. We got our track set up. All right, now that we got the sketch done, we should be able to go into structural member and our weldments. And then just like before, we will just start selecting these guys as the pipe. I should be able to do one side and then the other. So let's just kind of hide this. Looks like some pretty cool track right there, eh? And then just hide this sketch. There's a couple little bits of cleanup we got to do, so we'll go back to plane 5 here. And then, like I said, if we just need this to butt up, we'll trim this guy. We'll go this, trim it. Maybe we'll go the second direction by just like 0.001, like something itty bitty to clear it up. Oh, I need to go further. My bad. Way out there. Beautiful. And then we'll do the same on the other side. Just trim this guy up. Bada bing, bada boom. That was pretty exciting. I think it turned out really good. you can do a lot more from here. You can go and add supports, you can add the bosses that connect everything. It looks kind of wonky, but it is straight on the plane. Oh, I didn't combine it, so we'll just combine, insert features, combine. That just kind of unifies everything. Let me grab everything, see if it fixes that. So, okay, there we go. So now it's one face. So yeah, thanks for joining me. This is Intamin Track. Next time we'll see what other cool things you can do with no limits data. Like, you can do anything. There's no limits. It's awesome. They got the name right on that one. And bringing this into a CAD environment is really straightforward. You just have to be methodical and then set it up so that you can go through every track section that you created and bring it in and do whatever tweaking you need. So this is just another example of some of the cool things you can do. Last time we just focused on curves and adjusting our guide rails. This time we're kind of focusing on point clouds and how you can just bring in all your points and use those points to sketch. And then next time we're gonna do some more track design that uses some other methods. So every video is kind of repetitive with the setup, but I want to show you something unique every time, and I think that's valuable. So with that, I'm going to let you go. Like and subscribe. If you want to see something as far as designing track goes, let me know in the comments below. Let me know anything, how you're feeling, what day of the week it is. I don't know. I'm going to just spam my comments now. That's the ultimate test if you watch the whole video. So I'll see you on the next one. Peace.